In this lesson, let's take a look at how to render out these particles. So we have our cache here. It's looking pretty groovy. It's all dancing and being cool. Let's see what happens when we enable this RuneSimd and hit render. And this is what will render out. And this looks kind of funky. It looks like some weird sort of like alien goop weirdness. It's not good. This is bad news. So what is going on? Why do we see this? How can we break down what we see? There's definitely the color going through, as you can see. But allow me to explain. Here we have our points that are our cache, right? And these points by themselves are only really locations. They're just locations in space. And when Mantra, our render engine, goes to render something, it's going to automatically place little spheres at these locations. And it's also going to read all of the attributes that are on those points. So that's why we have the color and the spheres. Now, back in our scene view here, let's work on applying some materials and adjusting this. So I'm actually going to go to the material context now. Let's create our own principled shader for our particles. And we can call this, let's say, particles material, just like that. Drag and drop to apply it. And now if we hit render, we will have a bunch of gray spheres here in a minute. It's actually going to take a minute because we have this backdrop or this marble platform. So to save us some time while we do this, I'm actually going to go here to our RuneGeo and turn that off just for a minute. There we go. This will be helpful for what we're trying to do. Okay, so we have our particles material applied to all these spheres, and basically the material will act like a material that's applied to a sphere. So if we wanted to go up here and let's say make it really metallic, let's say we wanted this to look like a bunch of gold flakes or something like that. We can even go up to this little cog here and pick a preset. So if we go here to gold, you'll notice that now we have some golden particles, which looks pretty darn cool. But basically the shader works like any other shader you might imagine. It's just being applied to these spheres. So we have that. But how do we actually decrease the size of these spheres? Well, if you remember back to our old friend p-scale, that attribute is what is responsible for determining the size of these spheres. So let's say we want to randomize p-scale for every single particle. A great node to use when doing that is the attribute randomize. So attribute randomize, plug that in, and we want to adjust an attribute name called p-scale. P-scale is a point attribute. It's attached to our points. And right now, I'm just going to change this min value and max value to something like, let's say 0.01, and we will say 0.1. So right there, let's hit render and see what we have. There we go, we have this. And you'll notice that we have now successfully changed the size of all of our points. However, right now they are still looking pretty big. So instead of 0.01 and 0.1, let's try this. Let's try 0.0025 and we will try 0.05. No, 0.005, like that. And let's see what that does. Okay, now that that is done rendering, this is looking to be a bit more of like the scale that we are hoping for. It's difficult to tell how much variety is going on right now in these different particles, but we do have a variety happening between 0.0025 and 0.005, which is good. Okay, so there's that. Now, another thing I want to point out here while we are on this topic is that we have all of our color still going through. But on our shader, our base color is set to just one color. And you might be wondering, well, why is that happening? it's because of this use point color option right here. That use point color is saying, or is telling the principled shader to be on the lookout for that CD attribute, and once it finds it, to then multiply whatever color that is against this color right here. So that's what's happening between our attribute CD, our point color, and our base color with this shader. Now, I don't want to actually use this metallic shader in this particular example. Let me show you guys a cool little trick that we can use to get a cheap render out of this and still make it look cool. I'm going to go to my metallic here and set it to 0, turn off my reflectivity, and as far as the base color goes, we don't even need any base color. I'm just going to set this to black. And instead of using this base color, I'm actually going to use emission at the bottom here. And this emission color is basically going to tell these particles to act like a light. So if I increase this emission to, let's say, white, and I hit render, it's going to basically be a little light source for each one of these spheres. And right now it's going to totally, not look good or anything like that, just because, there's just not a whole lot of variety going on. We just have white. But what we can do is, instead of using this white color for the emission, let's bring in our CD attributes that we defined on our points and feed that into the emission color to give all of these different lighting effects. So while we are in this material context, the way you can do that is by using a bind node. And this bind node is really, really important. In the next chapter, we're going to be getting into a lot of vecs and vops and things like that. And when we get there, this bind node is really probably one of the most important nodes to first learn. What the bind node does is it looks out for an attribute and it brings it in. So in this case, I want to bring in CD. And my data type, which again I'll cover in more detail later, is going to be a vector. In other words, a set of 3 values. Now, under the surface tab here, we can then connect this to our emit color. And by doing this, we will now have all of our colors back. And it kind of gives this cool rainbow-like effect. Okay, so we have that. It still doesn't look very good yet, though. And the trick to this that I found is that if you go to our opacity here and we turn the scale all the way to 0, in other words, we have completely transparent particles, we're going to get this kind of buildup effect that happens. In other words, as particles overlap each other, it's going to get brighter and brighter. And if I take my emission intensity and I change it to something like, let's say 0.1, your values might be different than mine, so you just have to play with it. If I do something like that, in areas that overlap, it's going to get brighter, and in areas that don't overlap very much, it's going to stay darker. Okay, so we have that, and if we bring back our grid plane, let's just get an idea of where we're at here, or bring back our marble. Let's see how it looks against that. And this is the result that we get. Overall, that marble makes a huge difference on what we're actually seeing here. So it's a good idea to turn that on every now and then just to get a context for where this is going to be at. But as you can see, we have the beginnings of what this effect will be. Now there's one more thing that I want to do to our geometry before we start finalizing all of this. We have our basic shader set up, but what if we made cool little strands that were just kind of waving around? You might remember back in the little teaser at the beginning of this chapter how it was that cool sort of hairy look almost, where it was just kind of like dancing around. Well, I'm going to show you that in the next lesson and also use that as an excuse to talk about substeps and what substeps are, as well as what subframes are within a simulation.